and using a modem, an analog modem to go ahead and dial up and connect to other offices. That's one WAN technology, one that we don't see really used anymore, but one that still exists. Another one that we have is the T1 or E1, depending on what country you're in. Matter of fact, technically there's even a J1, but we're not going to get into that. But a T1 is a digital leased line consisting of 24 64K channels, providing a total transfer rate, if you just do the math, of 1.544 megabits per second of throughput. Now the E1 is the European version, which actually has 30 channels instead of 24, providing a little bit faster speeds up to just over 2 megabits per second. A T3 or an E3 line is the exact same thing in the sense that it's a digital leased line, but a T3 is basically 28 T1 lines or 672 channels as opposed to 24 channels, providing a transfer rate up to over 44 megabits per second. And an E3 again is the European version, which has 512 channels, providing a little over 34 megabits per second. Now these are dedicated leased lines that you would need to get from a telecommunications provider. Another option that we have, although somewhat out of date, is something called ISDN, Integrated Services Digital Network. Now, the main thing you need to know about ISDN is that there are two different flavors. There is basic rate ISDN, which uses two 64K B channels, which means you're going to get 128K of throughput on your data. And it also uses a 16K, what's called D channel or Delta channel, to transmit the control information about the transmission. And primary rate ISDN uses a total of 24 64K channels, 23 of them as B channels for data and one D channel for control information, but essentially giving the same throughput as a T1 line, right? Because a T1 line is 24 64K channels. Moving along, here is something that was mentioned in the last video, something called SONET, Synchronous Optical Network. And we'll also talk about OCX, or optical carrier levels. Now, again, I don't want to get too deep into this. It really will just confuse things, but SONET is a network technology designed to carry large volumes of traffic over relatively long distances via fiber optic cabling. Now, I will tell you, besides the fact that it's done over fiber and it's very fast over long distances and all that good stuff, it's also typically done in the form of a ring. You may have heard the term SONET ring, and it's actually a form of dual ring so that you can have fault tolerance and very high speed throughput. Now, the actual data rates of your SONET network are divided into your optical carrier levels. And at the bottom of the screen here, I have the different OC levels, where basically we have something called OC1, which is a little over 50 megabits per second, ranging all the way up to OC768. And I will tell you, that's not as high as it goes. It does go higher than that, but OC768 would be 40 gigabits per second. So you can see there are some pretty fast speeds involved with SONET. Now, the one thing that I will tell you that you don't really have to worry about memorizing a chart like this. Okay, and the reason why is because all you really have to do is take OC1. So if you just know that OC1 is 51.84 megabits per second, and you just multiply it by whatever number we're talking about. Like OC3 is just 51.84 times 3 to give you 155.52. Okay, so you don't have to memorize the whole chart. I just wanted you to understand that there are many different optical carrier levels involved with SONET networks. Now, another type of WAN technology, matter of fact, here we have a couple of WAN technologies which use packet switching. The first is something called frame relay. Frame relay is a WAN technology where all nodes in the WAN network, or that's kind of redundant, right? WAN network, because WAN is wide area network, are connected through what's called a packet switching cloud. Now, the main thing that I want you to know about this is that if you're going to get frame relay, what you do is you pay a base price to the carrier for what's called a committed information rate, or a CIR. Now, this is like a minimum rate of throughput. But beyond that, there may be more throughput available. There may be more bandwidth available. But what I can also tell you is, besides the base price just to have a certain level of guaranteed bandwidth available, you then only pay for the bandwidth that is actually used beyond that small minimum base price. Okay, so you're basically just paying a base price to turn the network on. And actually, I should clarify, not only are you turning it on, but that base price will vary depending on what the guaranteed fastest speed is. But you may not ever use that fastest speed. You may not, and it's not even so much the speed as much as the overall throughput. You may not use all of it. You may have a situation where most of the time, most times of the day, maybe even most days of the week, you need a very small amount of throughput. But then maybe, we'll even say, how about once a month, right? Month end or something. You get some kind of massive data that you've got to get from point A to point B. Well, what happens is for most of the month where you're only using a little bit of bandwidth, well, you only pay for a little bit of bandwidth. But when you need that huge chunk of bandwidth, you need massive throughput, it's available because you paid that base price to get it available. And when you use it, well, then you got to pay for it. Okay, it's sometimes known as bandwidth as needed. Now, another one that's somewhat similar is something called ATM. No, not automatic teller machine, not where you go to get money, but asynchronous transfer mode. This is an advanced packing switching network which uses fixed length packets. They're actually 53 bytes in length. Every single packet, no matter how big the data is, it's going to be divided into 53 byte packets, and it can provide data rates up to 622 megabits per second. And actually, it has been known to be double that. It's been known to be a little over a gigabit through compression. So, ATM, the main thing I want you to remember is the two bullet points I have here. 53 byte fixed sized packets and data rates up to 622 megabits per second. Now, there's another technology that we have to talk about here, and it's something called MPLS, which stands for Multi-Protocol Label Switching. Now, this is an interesting technology because you'll notice here it's not an actual service or an actual technology like many of these others, but it's a technique. Okay, it's more of a process of how WAN communication can take place. And because of this, it can be known by many different names. In other words, different carriers are going to implement the MPLS technique, but then go ahead and assign it some other name, some other marketing related name, because MPLS is not an actual technology. Now, the primary concept that I want you to keep in mind about what this is, I mean, first of all, look at the name, multi-protocol label switching. Well, multi-protocol, again, it's because it's not one specific protocol, it's not one specific service, it's not one specific technology. It works over many different protocols, services, technologies. And then we have label. Well, that's the primary concept. It uses what's called labeling. Now, it's very difficult to explain exactly what is meant by labeling and how this benefits without having a good full understanding of routing, routers, routing tables, etc., etc. And we're going to get to all that later on in the course. But for right now, the general idea is, keep in mind that typically when a piece of data or a packet of information gets to a router, the router needs to then analyze each one of those packets independently to figure out where it's supposed to go and how it's going to get there. Well, the idea behind labeling is that what we can do is when a packet first enters into a network, it can be assigned a label, which gives the router kind of a quick piece of information so that it can quickly know how to get that packet to its destination without having to do a thorough analysis. Okay, so really what it's doing is it's kind of streamlining the process of going through different routers within a network. Now, again, you're probably going, huh? What? And you're feeling kind of lost because we really haven't covered everything we need to cover in order to understand or fully understand what this MPLS is. So there's a couple things I want to tell you. One, we are going to cover everything you need to know throughout this course to be able to grasp the definition of MPLS. And then second is right down here, I have a URL to what I think is a pretty good site out on the internet. It's actually through networkworld.com, where they have given a thorough explanation, including complicated diagrams and everything, of how MPLS works. So I wouldn't recommend that you go to this website right now, but after you've completed the course, once you've listened to everything and you fully understand how routers work, how routing works, etc., how things like the OSI model work, then go read this article. It's a very well explained article. All right, now we get more into the kind of the internet connectivity stuff as opposed to making connections to different offices. And we'll talk about where this can come in handy for connecting different offices in just a few minutes. But here we have DSL, Digital Subscriber Line. You've probably heard of DSL. DSL is quite popular for many of the home users, but it's also used in offices. DSL provides high-speed internet connections using the standard copper telephone wires. Right? In other words, DSL, who provides it to you? The phone company, that's right. Well, DSL also comes in different flavors. There is ADSL, which is asymmetric digital subscriber line, which allows POTS, the plain old telephone service, and data to be transmitted simultaneously over the same lines. Now, one of the things that you should know about ADSL is that typically your download rate is faster than your upload rate. Okay, that's how it's designed, is to go ahead and give you more download throughput by reducing your upload throughput. SDSL stands for Symmetric Digital Subscriber Line, and it cannot share data transmission with POTS. Okay, so unlike asymmetric, this cannot share data. You actually need to have separate lines, one for data, one for the actual phone service. You also need special hardware for SDSL, and you will see that it's not that commonly used. Now, the last one we have here is something called VDSL. I love it. They put a V in there for very high speed DSL, basically. And I'll tell you, VDSL is something that is somewhat new, not necessarily heavily used yet, not very well known about, but basically it's a concept that it's a technology that allows access to the maximum bandwidth available on your standard copper phone lines, which would be anywhere from 13 to 55 megabits per second, which actually is quite fast relative to your typical ADSL, which is going to be closer to somewhere between 1 and 3 megabits per second. All right, moving along from there, talking about internet connectivity, we have cable modem, where we get a high-speed internet connection through your broadband cable connection, same way your cable TV comes in. You've got satellite internet connectivity, where again, high-speed internet connections